Hi students, welcome back to part 2 of the e-lecture on Gateway 2 of Tectonics, where we learn about the associated tectonic phenomena that we find at plate boundaries. So again, the tectonic phenomena that we're learning about are earthquakes and volcanic eruptions. Let's first look at earthquakes. Now, earthquakes are a vibration in the Earth's crust caused by the sudden release of stored energy in the rocks found along fault lines. So this is an overview of what we're going to learn on earthquakes, paths, extent, locations, and the hazards of living in these areas. Now first, let's start with the paths. The terms that you need to know about earthquake include focus, epicenter, and aftershocks. Now, earthquakes occur when plate movements along plate boundaries cause the build-up of stress, and when the rocks can no longer withstand the mounting stress, they will slip many meters, causing the earthquake. Now, an earthquake releases energy in the form of seismic waves. Seismic waves radiates out from the point of sudden energy release, called the focus, which is underground. The point on the Earth's surface directly above the focus is called the epicenter. Now let's see how the AFP explains this with their beautiful voices.
These huge plates are constantly in motion, and when they collide, one is pushed slowly beneath the other. The resulting friction creates energy along the fault lines, which eventually becomes so unstable they rupture, sending out a shock wave. This energy release is felt as an earthquake. After the initial jolt, aftershocks can be felt as neighboring plates readjust into place. Most underground movement goes unnoticed by human beings, but occasionally a big tremor strikes.
So this video can actually be found in the Google slide, and you can always refer to that in our website at tinyurl.com/HIUSG, all in capitals. Now we use the Richter scale to measure an earthquake's magnitude, which quantifies the energy released by an earthquake. Surprisingly, 6.1 is not 10% stronger than 6. Each level is actually 10 times stronger than the last, meaning 6 is actually 10 times stronger than 5. Alright? This energy is measured using seismographs and more high-tech versions called seismometers. Here's one in action. You can see it on your own at the slides. Again, available at the website. Now, apart from its magnitude, the extent of damage caused by an earthquake may vary based on other factors. Obviously, stronger earthquakes will cause more damage, but there are many other factors that will change things as well. The first of which is population density. Now, earthquakes in densely populated areas, such as cities, cause more damage than in the countryside. Obviously, this is because there are more buildings, more homes. The time of occurrence can also be very important when earthquakes happen at day versus when they happen at night, because this affects people's chances of survival due to what people are doing and where they are. Tainan's earthquake at 4 a.m. killed many people in one particular apartment block because many of them were sleeping. Christchurch's quake happened in the morning, which allowed people to run to safety. The level of preparedness of cities can also make a huge difference. Cities where authorities and people work together to prepare with evacuation plans, trained rescue workers and action plans, together with alert systems, allow people to get out of danger, making earthquake events and damage more manageable. The distance from the epicenter can also make a large difference. Of course, the closer you are, the more danger you're in because the more shaking is happening. Now, the type of soil can be particularly important. Certain soils can be looser and unconsolidated, which amplifies seismic waves. Saturated and unconsolidated sediments, which means that they are not stuck together like in rocks, can even be affected by liquefaction, which is where the ground becomes unstable and the soil flows like it's a liquid, causing scenes like this vehicle, which sank into the previously solid ground during the Christchurch, New Zealand quake. Now, earthquakes can occur at any plate boundary, but occurs most frequently at convergent plate boundaries due to the great buildup of stress where plates push against each other. Some examples include the Japan earthquake of 2011 and the Indian Ocean quake of 2004. About 3/4 of earthquakes that occur each year are found along the Pacific Ring of Fire, but some earthquakes may also occur some distance away from known plate boundaries. One example is Sichuan, which has experienced a quake every 20 to 30 years since better kept records from the 1933. This is due to deformation and fracturing of plates along the plate during subduction, which can affect large areas. Now, the hazards associated with living in earthquake zones include threat of tsunamis, disruption of services, fires, landslides, destruction of properties, destruction of infrastructure, and the loss of lives. The corgis have appeared again. Please remember to copy. Now, the first hazard that we are going to study is the threat of tsunamis. Tsunamis refers to unusually large sea waves that are caused by the movement of the seafloor during a large earthquake at subduction zones. So it may also be caused by an underwater volcanic eruption or an underwater landslide, and a landslide above sea level which causes materials to plunge into the water. So this is an example of the Japan tsunami, how the tsunami really pushed inland. You can see this on your own. Now, this is how tsunamis actually form. Due to an earthquake in this area, okay, it causes the water to be pushed very quickly towards land. And as it reaches shallower land, the greater friction slows the waves and causes them to increase in height. So this is the one from your textbook. Let's look at some other diagrams which may show you more easily what happens. So we look at waves in terms of circles, and as they travel on, these circles are pushed upwards, which causes them to get a lot higher. Another which shows you how the water recedes and then is pushed up. Okay, it shows you how the water bunches together really, and how it displaces a great volume of water. Okay, another one again that shows you this, so you can look through this on your own in the slides. Now, this is the damage that the Tohoku earthquake tsunami caused. You can see that the destruction is very much massive. Earthquakes can also cause disruption of services, as the electricity, gas, and water of a city are typically run underground. So the Kobe earthquake in 1995 actually disrupted the services to 1 million of the city's 1.4 million residents. Now, earthquakes can also rupture gas pipes, which can provide fuel to start fires. If you remember in the video on the tsunami, which you should watch on your own, okay, you see that fires start to erupt. So this can happen quite often. So this is the 1906 San Francisco earthquake, and this is the Kobe, and this is in California. So this actually is a very common phenomenon. Now, landslides can also happen because of earthquakes, so you have to watch this on your own again. Now, landslides are rapid downslope movements of soil, rock, and vegetation. It can also happen in the form of mud flows when there is heavy rainfall, and these can thunder down and cause losses of homes and also losses along roads and high number of deaths. So this is when the earthquake hit Taiwan again, the recent one. And earthquakes can actually cause the destruction of properties and of course many homes. So a lot of people may be left homeless after the disaster. This is from the Haiti earthquake, where you can see that even though the homes are really very low and very short, everything is out on the streets because it's just so broken up. Okay, and this is from the Kobe earthquake. You can see a whole building collapsed. Now, another important thing that earthquakes damage is actually infrastructure. So earthquakes can cause cracks to form in infrastructure such as roads and bridges, which disrupts transportation, and as you know, there's snowballing effects because this prevents fire services, ambulances from getting to people who need it. So all these damaged roads actually cause a lot more damage than you would think of because of the flow over effects. So this video actually shows you the after effects of the Taiwan earthquake that happened recently as well. So you can see the loss of life that has happened in Tainan because of it. Now, although it's minor because that city is so smaller, but great loss of lives have happened because of earthquakes. So you see in this map the record of the number of deaths and injuries, or just number of deaths that happened during the Nepal earthquake in 2015. Now, although the epicenters are actually here and here, most of the deaths happen in the center area because that's where the capital is, where it's extremely densely populated. So from this graph, you'll see that the number of deaths in due to earthquakes since 1990 are quite significant. And although there's no clear trend because earthquakes are more unpredictable and they don't happen in a pattern, you can see two spikes here, the highest of which is in 2004 due to the Indian Ocean earthquake and mostly due to the tsunami that happened, and also in 2010 due to the Haiti earthquake. Now, you can see that earthquakes on their own actually don't cause most of the deaths, but the other hazards that come with it actually cause much more deaths. So the Haiti earthquake wasn't a tsunami. Well, there was actually on the coastal areas, but a lot of the deaths actually were caused by the damage to infrastructure and the inability of aid to reach fast enough. So a lot of people starved to death or died of other related diseases afterwards, which is why that death toll actually kept spiraling out of control. So earthquakes are one great hazard and one great phenomena where they're really just are hazards and just very dangerous. So we must learn to deal with it. So volcanic eruptions are the second phenomenon that we'll be learning about in this EVE lecture. Now, volcanic eruptions can happen both on land and on the seafloor, and we define them in three different ways. We either classify volcanoes as active, which refers to volcanoes that are currently erupting, or dormant, so they are currently inactive or sleeping, and extinct, which means that we don't detect any current seismic activity at these volcanoes. So there are four risks of living near volcanic areas. The first is destruction by volcanic materials. Now, these volcanic materials can cause widespread damage of property because blow-silica lava moves slowly but will rather rapidly over long distances if there are great slopes. And pyroclastic flows of stratovolcanoes can travel much faster at more than 80 kilometers per hour, destroying everything in its path. Just inhaling it is harmful. And of course, there are volcanic bombs, which are rocks that are up to the size of a car that flies in the air and rolls down the mountain. So these are pretty terrifying and cause wide-scale damage. This is a picture of Mount Pinatubo expelling its pyroclastic flow in 1981, I think. So that was the second largest volcano eruption recorded in the 20th century. Landslides is another thing that can happen due to the structural collapse of a volcanic cone. So this can obstruct the flow of rivers, which causes floods and blocks roads, and then therefore buries villages and farmlands. And the mixing of pyroclast and glacial ice can also trigger lahars, which are again landslides from hell. Another thing that can happen is pollution, not in the sense that we usually think of it, but because of the ash, which can block sunlight, suffocate crops, and cause severe respiratory problems, just like haze does. So think of haze times 1,000. And the release of gases can be very harmful to people. Carbon dioxide, carbon monoxide, and sulfur dioxide. Now you'll be very surprised to hear this, but carbon dioxide can kill because certain lakes actually hold on to the carbon dioxide that's caused by minor volcanic eruptions, and then when they finally erupt and burp, that carbon dioxide can overpower people, cause them to faint and die on the spot. You don't believe me? Read about Lake Nyos in Cameroon. So ashes polluting the air, causing great disruption in air traffic back in 2011 from the Icelandic volcanic eruptions. Now, the sulfur dioxide released from volcanic eruptions can also cause the weather to change. This sulfur dioxide actually reacts with water vapor to form sulfur-based particles, which reflects the sun's energy back into surface and temporarily cools the earth for periods of time. So you see that this surface actually cools because of it, and the greatest volcanic eruptions in the past 200 years have actually caused months of climate change. We've learned about that in weather and climate, by the way. Now, the benefits of living near volcanic areas are also quite multiple. Of course, we'll get fertile volcanic soil. Now, volcanic soil is fertile because it's new and it's fresh, but it requires time to break down. So these minerals are available after rocks have broken down, and this causes agriculture to flourish in that area, which is why Mount Merapi in Indonesia is flourishing. But people, have to run away when there are volcanic eruptions, but they run right back afterwards. Okay, volcanoes also bring with them precious stones. So diamonds, sulfurs can be found there, and these resources can be extracted after millions of years, but they are very precious because they can only be found there. Tourism can also be offered because of this, and volcanic areas actually have a lot of different things that people enjoy. So ruins of Pompeii are very popular, as are hot springs. And lastly, geothermal energy can also be brought up because of those bricks that happen in the Earth's crust, and the hot water or steam can be harnessed to produce electricity. Which brings us to the end of this key question on tectonic plates. So I hope you have learned enough, and all the best for your tests. Bye!